Good day, everyone. We'll be dealing with further mathematics today, and the class is going to be for all senior classes from SS1 to SS3. Normally, you guys have done indices before initially, but the indices we'll be doing under further mathematics might be a little bit complex, so you guys have to be very attentive throughout the class. So I'll be stating some rules, and I'll be including some rules in which you guys have done in your SX1. For SS1 students, you guys have done it already in first time, but I'll be stating some new rules that you guys might not have heard before. So please listen carefully. And if there is anything you don't understand, you can just tell the person in charge to let you to backward the video, so you can just catch up again. I hope you guys are with me. Now, the first, I have the laws of indices here. Laws of indices. Indices, if you're seeing a very big questions under indices, initially it might look complex to you, but as far as you understand the rules of indices, the laws of indices, and how to apply them, you won't have a problem. You just have to break them down bit by bit, then you are good to go. So the first rule I'll be stating here I'm having, if you're having x raised to power a multiplied by this multiplication sign, multiplication x raised to power b, or let's just, okay, so you guys will understand, let me just put my x this way, x raised to power a multiplied by x raised to power b. This will give me what? X raised to power a plus b. You have to be very mindful of something. If you observe here, I'm able to do this because I'm having the same base. The same what? The same base. That's why I'm able to do this. Okay, now, but in a situation whereby you're having x raised to power a multiplied by y raised to power b, this one is wrong for you to say it is x raised to power a plus b, or it is also wrong for you to say it is y raised to power a plus b. Why is it wrong? Because we are having what? Different base. Am I communicating? When the time comes, I'll be talking about when we're having the same power. There is also a law for us when we have different bases but the same power. There is something we can do about that as well. But let's start from the basis as we are here. Okay, the second law we're talking about here is what? Here I'm having x raised to power a divided by x raised to power b. Since multiplication is what? Plus, division will be minus. This is x raised to power a minus b. At the same time, this can be written as x raised to power a over x raised to power b. It is still the same thing. This is also x raised to power a minus b. That's number 2. The third rule I'll be stating, we all know, if you guys don't forget, that any number raised to power 0 will be what? 1. 1 million raised to power 0 is 1. 2 million raised to power 0 is 1. Even your master Goki, raised to power 0 will be what? 1. Thank you. So I'm having x raised to power 0 here will equals what? 1. So any number raised to power 0 will be what? 1. Mommy Akorede raised to power 0 will be what? 1. So anything raised to power 0 will surely give you what? 1. So please take note of that as well. Another rule I'll be stating here is what? If you're having x raised to power number 4, you're having x raised to power minus a here. Whenever you have a negative means it is an inverse. Am I communicating? Whenever I say inverse, that means it is having 1 over. X raised to power minus a here means 1 over x raised to power a. Am I communicating? At the same time, I can have something like y over x into bracket raised to power minus 1. This one, y over x raised to power minus 1, it also means what? Inverse. It means inverse. And this can be also be written as x over y. Am I communicating? What do I mean by inverse? For example, to over y, call 2 over 3. The inverse of 2 over 3 is 1 over 2 over 3, and that equals what? 3 over 2. How will this give me 3 over 2? It will be 1 over 2 over 3, it must be 1 divided by 2 over 3. And we all know that division changed to what? Multiplication. This means I'm having 1 times 3 over 2. When division changes to multiplication, you know, numerator becomes denominator becomes numerator. I mean, so that's why I'm having 3 over 2. Or to the inverse in the reciprocal. So, you know, don't forget that I said whenever you have minus, it means 1 over. So this one means 1 over y over x. Tabawa solve where they like x over y. That means it is going to what? Change. And at the same time, if you are having 1 over x raised to power minus a, this is going to give you x raised to power a. What I say is going to give us x raised to power a. Don't forget that our minus is what? 1 over And at the same time, when you're having x raised to the power minus 1, this will give us what? This is negative power. I'm dealing with negative power here in this aspect. X raised to the power minus 1 here will give me what? 1 over x. So here now, you guys just have to listen very attentively. Now here, if you look at this here, I said 1 over x raised to the power minus a will give us what? X raised to the power a. Is I think at this point the video can just be paused so that you guys will write this law that I've stated, because we'll be needing it. So the video will be paused for you guys to write, then you continue when you guys are done. But for the sake of time, I'll be cleaning this now. Earlier I said 1 over x raised to the power minus a x raised to the power a. Key reason. Don't forget I said in the negative law, whenever you have negative, it means 1 over something. So this means 1 break it down, the 1 over x minus it to the 1 over minus become 1 over a. H over a. This now we cancel this. So this becomes x over a. Take over here, the reason to be cancel around. You know, this is the same thing as 1 divided by 1 over x. Over the 1 times x over 1. You know, everything is what? Raised to our a. Raised to our a. Sure of me, 1 times x is what? X over 1. Abi, raised to our a. And x divided by 1 will give us x. That's x raised to our a. That's how I'm having this. I just have to break it down so that you guys will understand better. So I've written the law already there. Now here, let's continue. That's negative law. I have the power law as well. Yeah, if you're having x raised to our a into bracket raised to our b here, you're having x raised to our a into bracket raised to our b. You don't need to disturb yourself. Just multiply this and this together. This and this together. You have one x raised to our ab. You know, ab x raised to our ab. Now, when you're having x raised to our 2 into bracket x raised to our 3, this will give us what? X raised to our 2 times 3. That's x raised to our 6. Please, if you're having any further mathematics textbook and you're seeing them between number, they are putting points. Point means multiplication. At times, we don't write x raised to our 2 times 3 most of the time. Am I communicating? 2.3. Go to here, multiplication on somebody. That's 2 times 3. That's x to the power 6. Okay? Yeah, now, let's talk about the fractional indices here as well. I think this is 5th law. 5. So the 6th law we're talking about is when you're having x raised to 1 over a. X raised to 1 over a here is going to be into one side a into root x. For example, to one x raised to 1 over 3. We're going to one side 3 into root x. It is the cube root of x. If you have x raised to 1 over 2, it is what? The square root of x. 2 is already square root. So 2 but if it is 3, 4, 5, we write it. If it is x raised to 1 over 4, the 4 into root x. This means the 4th root of x. You know, 4th root means what? In time of multiply, x. 3rd root means in time of multiply, and cube root means in time of multiply, x. For example, I'm having the cube root of 8. Here it means what am I going to multiply 3 times? That will give me 8. And that's what? 2. 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. That's what that means. I hope you guys are with me. Okay, now that's for fractional indices. Now the last law we're talking about under this aspect here, if you're having 7, if you're having x raised to power b over a into one side, this will equals a into root x then raised to power b. A into root x then raised to power b. The 2 more. We're having x raised to power 2 over 3. That means we'll be having the cube root of x, then everything into what? Square. It is still under fractional indices. So one thing is you have to understand all these laws very well. Then how do we apply them? How do we apply them? I'll be explaining how we apply the first law. If I'm using the first law, I'll tell you I'm using first law. If I'm using second law, I'll tell you I'm using second law. If I'm using third law, I'll tell you guys I'm using third law. So just be with me. Now I'll be solving some questions here now. We're having a jam question here, UTME question here. The question I have here says simplify 8 raised to power 1 over 3 multiplied by 5 raised to power 2 over 3 over 10 raised to power 2 over 3. Now, how do I solve this? Okay, I think we're given an option. My option A here is 2 over 3, B here is 5 over 3, C here is 3, the cube root of 5, and D here is the cube root of 2. Yeah. Now let's solve this. How do I solve this? That should be the first thing that will come to your head. Okay, try to break big number to small number. Solution. This 8 here ought to be, 8 can be what? The cube root of something. 8 is the cube root of something. Am I communicating? Up nepa, I want to know. Now here, this 8 raised to power 1 over 3 here times 5 raised to power 2 over 3 here over 10 raised to power 2 over 3 here can be broken down to be, I can say my 8 here. 8 is what? 8 is the cube root of something. 8 is the what? The cube root of something. Am I communicating? So this can be what? 2 raised to power 3. That I multiply 2 11, 2 times 2 times 2, 2 times 2, 4, 4 times 2, 8. I multiply 11 of 1, so the cube root of 8 must be 8, so the 2 raised to power 3. Then into brackets, kilowatt 1 over 3 times 5 raised to power 2 over 3 over 10. Well, there is a relation between 2 and 5 to give us 10. That's 2 times 5 will give us 10. I can say this is what? If you think for the mathematics is 1 here, you have to think out of the box. There's something we call thinking out of the box. Okay, 10 eléyìí mi ò lè sọ, kò sí nǹkan tí mo fẹ́ fi 10 ṣe kí n máa sọ di power, kò sí tó máa fún mi ní power 10 lẹ́yìn 10 raised to power 1 nìkan ló máa fún 1 10. There is no number. Is there any number that we can raise to a power that will give us 10? No. But I'm having 2 here, I'm having 5 here. Then surely there is a relation between that 2 and that 5. Am I communicating? So here, I'll say this is 2 times 5 raised to power 2 over 3. Am I communicating? Okay, let's continue here. Now, let's apply rule 5. The law of indices 5 to this one, where I say x raised to power a into bracket b. This will become what? X raised to power a times b, ab. Am I communicating? 3 this is our a, this is our b. 2 raised to power 3 times 1 over 3. Are you guys with me? We are having 3 times 1 over 3, 1 over 3 there. Yeah, 1 over 3 initially. 3 times 1 over 3 multiplied by 5 raised to power 2 over 3 over. Now, because this has a common power, they have what? A common power. I can split this to become 2 raised to power 2 over 3 times 5 raised to power 2 over 3. When I explain the first law, that we're having different base but the same power. Only for example, only x raised to power a times y raised to power a. Only x times y raised to power a. Ìyẹn ni tá bá ní different base, same power. Ó yàtọ̀ sí ká sọ di x raised to power a plus a. Ó wrong, eléyìí wrong. But we are having different base, same power. And so divide x times y raised to power a. That one is as well correct. Ìyẹn la lò bí báyìí. Ẹ lè fi yẹn náà kún law of indices yín. Mo fún yín nìyẹn lọ́fẹ̀ẹ́, mo fún yín lọ́fẹ̀ẹ́, má sanwó ẹ̀. Kí yẹn di number 8. X raised to power a times y raised to power a will become x times y raised into bracket raised to power a. Write it down as well. Okay, now let's continue. Here now, 3 cancel 3 here, right? So this here I'm having 2, this is 2 raised to power 1, 2 times 5 raised to power 2 over 3 over 2 raised to power 2 over 3 times 5 raised to power 2 over 3. Then what do we do here? Let's apply the division law. Division rate. I need 2B, I need 2B, I need 5B, I need 5B. Am I communicating? This means Timbama took in equal. Automatically 2 times 5 raised to power 2 over 3 divided by 2 raised to power 2 over 3 divided by 5 raised to power 2 over 3. Am I communicating? Tí ó bá tún wá yí ẹ bẹ́ẹ̀ yẹn náà, o lè split ẹ̀, o ṣe báyìí pé 2 over 2 raised to power 2 over 3 times 5 raised to power 2 over 3 over 5 raised to power 2 over 3. Now let's go and use the second law. Ibi tí mo ti ní tá bá ní x raised power a over x raised power b equals x raised power a minus b. O rí pé the same base lélẹ̀ 2 lélẹ̀ 2 lélẹ̀ 5 lélẹ̀ 5 lélẹ̀. So lè mọ̀ wá di kíni 2 raised power 1 minus 2 raised power 2 is the same thing as 2 raised power 1. 3 is the same thing as 3 raised power 1. But we have to see 2 raised power 0. So yeah, my 2 raised power 1 minus kilo lélẹ̀ 2 over 3 times 5 raised power 2 over 3 minus 2 over 3. Now, 2 here, the SM here is what? 3, right? 3 times 1, 3 minus 2 times 5 raised power 2 over 3 minus 2 over 3, this will give us 0. So what am I having here? 3 minus 2, that's 1. I'm having 2 raised power 1 over 3 times 5 raised power 0. Any number raised power 0 give us what? 1. So the answer here is what? 2 raised power 1 over 3. Do we have our answer here? Ah, 2 raised power 1 over 3 lani. Now, go back to when I started doing fractional indices. What I said, if you're having x raised to 1 over a equals a into root x. I need 2 raised to 1 over 3, right? Ele ma di kini, into one it alako ma do one side na ma go sita add 3 into root 2. So we're having the cube root of 2. What's our answer? The cube root of 2. Our answer here is D. E pato fún mi be yen, e pato kí n ma gbo àtẹ́wọ́ yín níbi tí mo wà bí láti ọ̀dọ̀ yín be yen. That's 1. You can see I break this thing down step by step, step by step, step by step. The thing is, even if you don't understand, you cannot grab something you're new to once. You have to practice as well yourself. Learn how to practice yourself. Am I communicating? If you learn how to read yourself, nothing will stop you. But if you don't learn how to read yourself, nothing will help you. So, I don't know if you guys have gotten this already, but I think you can just backward the video and pause so you guys can write. I don't want to waste time. I still have a lot of things to do. Okay, let's solve another question here. Yeah, I'm having 3. Not coming to get on. Master okay, Macau. 3 into root, open bracket, 64 raised to power minus 6 into bracket 1 over 2. How do I solve this? Number to Toby, a Rakoko bar. Whenever you have something that deals with fractional indices like this, the first thing you have to do is what? Eliminate the roots. Now, the rule, I've forgotten the number to get x raised to power 1 over 3 3 into root x. So definitely I can reverse this to this. So I take a dilate pada lo si lu bi bai. Ka assume pe gbogbo to wa lu bi bai, òun ni x wa. 3 root 2 le àwọn fẹ́ dá padà sí bi bai. You know, ó máa di kíni? Open bracket 64 raised to power minus 6 into bracket 1 over 2. Then everything into bracket what? 1 over 3. X mi re òun gbogbo ele. Àbí x mi jàre òun gbogbo ele. Root 2 yìí, 3 root yìí, 1 over 3 yìí òun lele. Now, at the delay, let's now go back to the law that says x raised to power a into bracket b equals x raised to power a times b. Let's go back to that law. So, ile mama dikini 64r open bracket 64r raised to power minus 6 close the bracket raised to power 1 over 2 times 1 over 3. So here I'm having what? Open bracket 64r raised to power minus 6 into bracket 1 over 6. You know 1 times 1, 1, 2 times 3, 6. Now, I'm having 1 over 6. How do I eliminate 1 over 6? That's what should be with you. That's what you think of. Okay, I'm having r raised to power 1 over 6. Well, r raised to power minus 6 here. That's normal. Okay, I think, is this also an optional question? Yeah, this is also an optional question. I think first option here I'm having A, r over 2, B, 2r, C, 1 over 2r, and D, 2 over r. So let's continue solving. Now, I'm having 1 over 6. You know, at the same time, 1 over 6 is too much. My basis is this. I'm having 64 raised to minus 6. I mean, it's too many. But come about logic. Kill times 11 far to my 464. If you have a calculator with you, you can easily get that. But what's that thing that we can times 6 times that will give us 64? Let me hear an answer. What are we going to multiply 6 times? That'll give us 64. Mean bro. I believe someone there says 2, right? I want to believe that. You guys say 2. Okay, 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. And 32 times 2, 64. That's 2. So which means I can easily turn this to this. 2 raised to power 6. And then r raised to power minus 6. So 1 over 6. Ma wa dare láàmú jìnnà kò lọ far rárá. Mo ṣe kíni? Mo lọ far. Ele máa di apply this law again. Kó wá split wọn lẹ́yọ kọ̀ọ̀kan. You know méjèèjì ló jọ ní 1 over 6 because wọ́n jọ wà nínú bracket ni. Since the méjèèjì ló wà nínú bracket, 1 over 6 wà lókè. It this 1 over 6 is applicable to this and this. So 1 lọ far rárá, apply that law. So the 2 raised to power 6 times 1 over 6. Then this r raised to power 1 over 6. Okay, not over. Then r raised to power minus 6 times 1 over 6. 6 ele gé 6 ele dànù. 6 ele gé 6 ele dànù. Ó wá kù kíni? 2 raised to power 1. Then r raised to power what? Minus 1. Wá wá gbàgbé lọ tí mo ti sọ wípé tó bá ní x raised to power minus 1. Ó túmọ̀ sí kíni 1 over x. Àbí? So a ní r raised to power minus 1. Eléyìí túmọ̀ sí kíni 2 times 1 over r. You know 2 raised to power 1 is 2. So the answer here is what? 2 over r. Kí ni option wa? 2 over r. So a ní the option here is D. Ẹ tún pàtẹ́wọ́ fún mi. Now we've started our further mathematics class. I'm not hearing you guys clap. Oh. Clap me, Joe. You want to do yẹn àti party mo wo yẹn o pàtẹ́wọ́ àbí? Mo rí ẹ o pàtẹ́wọ́. Then now, I hope you guys are getting this thing. It is also what 2 over r. So we have our answer there. Just understand the law and when to apply the law. Indices is a very, very interesting aspect of mathematics. Okay, let's look for another question here. I'm having another UME question here. The question here says, please don't start with your can you pause the video, you can leave it call Kini because I don't want to waste time. So and at the same time, I want to believe you guys are writing as I'm explaining as well, or anyone that works for you. Normally, I don't like guys writing when I'm explaining. But I'm not there. I'm present. Look at this. I'm having the square root. 160 r squared plus another square root. Another square root here. What do I have here? 71 r raised to power 4 plus the square root of 100 raised to power 8. Tell me about all the question. You know, square root is what square root. Let's say we have an option here. We have an option here as well. A question is low you without 9r squared. B 12 into root 3r. C 13r. Then D the square root of 13r. Root tó ní yẹn ò kì í ṣe problem rárá. Kọ́kọ́ mú láti bí root kékeré bẹ̀rẹ̀ láti bí. You start from here. You don't start from the big one. You start from the small one. Okay. Solution. This will become the square root of 160r squared. And in mathematics, you don't skip a step. Mo ti mọ square root 100. What's how you got 10? No. Bó ló ṣe get it 10 yẹn jẹ́ kán mọ̀. That's how you get your full mark. You don't skip a step. 160r squared plus the square root of 71 r raised to power 4 plus here. Apply fractional indices. Now we monitor x raised to power 1 over a, a into root x. We explain like x raised to power 1 over 2, the root of x. So ilé di 1 over dá ilé padà sí bí by x wá lélẹ̀ nínú yìí. Root lélẹ̀ òun lélẹ̀ ń ta yìí. Ká wá dá padà ká sọ di open bracket 100 r raised to power 8 into bracket what 1 over 2 torí ó jẹ́ root. Root máa di 1 over 2. Cube root máa di 1 over 3. 42 máa di 1 over 4. 52 máa di 1 over 5. So here now let's continue. This becomes the square root of what? 160r squared plus the square root of what? 71r raised to power 4 here plus 100 divided by 10 raised to power 2 abi. Then r raised to power 8. Then 1 over 2. Are you with me? Now bí mo ṣe ṣe tẹ̀kan àwọn méjèèjì náà jọ ní 1/2 ká wá fún ẹnì kọ̀ọ̀kan ní 1/2 rẹ̀. Eléyìí di the square root of 160 r square plus root 71 r raised to power 4 plus 10 raised to power 2 times 1/2. Then r raised to power 8 times 1/2. 2 here 1, 2 here 4. Eléyìí di the square root of 160 r square plus I'm having the square root of 71 r raised to power 4 plus 2 cancel 2 equal 10 by 10 r raised to power what? 4. Now we need the same term. Then you r raised to power 4, r raised to power 4. Then I can do what? I can add, collect. We add the same term. You get that? That's just one mathematics. This one become the square root of 160 r square plus the square root of what I have here, 71 plus 10, that's 81 r raised to power 4. Are you guys with me? Then tún mú láti bí kékeré tó bá solve eléyìí bá ṣe solve with nǹkan bí báyìí eléyìí máa ní the square root of 160 r square plus then this one the square root of 81 is what? 9. Then the square root of r raised to power 4 will give us what? R raised to power 2. The same step that I used here. So we have r raised to power 2 here, r raised to power 2 here. Mo lè add méjèèjì náà bẹ́ẹ̀ yẹn. Eléyìí máa fún mi ní the square root of what? 169 r square. Then what's the square root of 169? The square root of 169 is what? 13. Then the square root of r square will give you what? R. That means I'm having 13r. That's my answer. The answer here is C. So this thing is very simple. Very simple. It's a simple logic. Okay. From there, I think I'll be giving you guys. Hey, sorry please. Otidaru. Okay, now let's continue, please. Yeah, I have just 2 more questions to go, and I'll give you guys an assignment. So probably I'll be explaining the answer you guys have to get with your assignment. Now, the question just says, without using tables, evaluate 343 raised to power 1/3 multiplied by 0.14 raised to power -1 times 25 raised to power 25 into bracket the raised to power -1/2. How do we solve this, guys? Okay, I think we have an option here as well. Option A, I'm having 12. Option B, 10. C, 8. And then D is 7. D is 7. So how do I solve this? Let's do this one after the other. This 343. And you're having 3 here. How many times? Low 3. Times lẹ́ẹ̀mẹ́ta tó máa fún wa ní 343. I want us to break it here. Times lẹ́ẹ̀mẹ́ta tó máa fún wa ní 343. 343. What's that? This 343, I think we're having 9 times 9 is 81. What is 81 times 9? We need to 81 times 9. 3 times 3 times 3 times 3 times 3 times 3 again. 9 times 3 27. 81 times 3 81. 81 times 3 is 81 times 3 is what? That's 3. 81 times 3 is 42. How many days for the period? This is not working. What are we going to multiply 3 times? I'll give it 3 for the period. What's that thing? I'm going to 3 for the period. Think of another number. Okay. 7 times 7, 49. 49 times 7. This is 63. This is 7 times 4, 28. 10 plus 6. That's 28 plus 6. That's 5. Okay, we've gotten our number. The number is 7. So here I'm starting this to what? 7 raised to power 3 into bracket 1 over 3 times you're having decimal point. The first thing you have to do is what? Turn your decimal point to fraction. So I'm turning this to fraction. How many zeros do I have here? 1, 2. 1, 2. In the power of 10, it will only 0 méjì. 100 will only 0 méjì. Well, actually, the 14 over 100. Then raised to power minus 1. Am I communicating? Times 1 over 25 raised to power what? 1 over 2. How you guys are with me? Now here this becomes 7 raised to power 3 times 1 over 3 multiplied by, you know, a something more explain. I said when you have y over x raised to power minus 1. This can become x over y. Which means I'm having 14 over 100 raised to power minus 1. This will become 100 over 14. Then times 1 over 25 is what? 5 raised to power 2. 5 raised to power 2 times 1 over 2. 3 cancel 3 here, 2 cancel 2 here. Then I'm left with 7 times 100 over 14 times 1 over 5. 7 here 1, 7 here 2. 5 here 1, 5 in this 20. 2 here 1, 2 here 10. That means our answer here is what? 10. That was option 10, 10, 10, 10, 10, 10, 10. That was option B. I'm having option B. That was option B. Please check this very well as well. Okay? Now there is water, so I have to just. How you guys are hearing? Now, I have another question here that says find the value of the expression 32x raised to power 3 over 81 minus 64x raised to power 64x raised to power 2 over 27 minus 81x raised to power minus 3 over 16. Only when x equals minus 3 over 4. When x is what? Minus 3 over 4. Okay, now what do we do here? How can we solve this? Let's break this to simplest term. I think do we have option here as well? Yes, we have option. Option A, 10 raised to power 1 over 2. B, 10 raised to power 1 over 6. C, 3 raised to power 3 over 8. Then D, minus 13 raised to power 1 over 2. You know here we have been given the value of x normally. So what can we do? 32 is 2 times 2 times 2 times 2. 81 is 3 times 3 times 3 times 3. 81, 16. Is there something we can do here? Or not, let me solve getting equal. You can just substitute your value here. And at the same time, you might substitute the value here. What can we do? You can turn it to the simplest term. Something is common here. 3, 3, 2. 2, 2, 3. Something is common. Are you seeing what I'm saying? Something is common. Probably without disturbing ourselves. Let's substitute. Well, it's already 32 over 81 into bracket. My x is what? Minus 3 over 4. Are we? Minus 3 over 4. Raised to what? Raised to 3. Into over 3x. Minus 3 over 4 is there. Minus 64 over 27. Into bracket what? Kilo. Minus 3 over 4 raised to power 2 minus 81 over 16 into bracket minus 3 over 4 raised to power minus 3. So I can turn this to what? 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2 32. This is I become it okay. Let's continue like this. 32 over 81 into bracket this minus 3 raised to power 3 will give us what? You know, minus times minus is plus. Plus times minus is minus. Minus 3 times 3, 9. 9 times 3, 27. Over 4 raised to power 3 will give us what? 4 times 4, 16. 16 times 4 will give you 20. Will give you 64. 64. Minus 64 over 27 into bracket. This is raised to power 2, really. Minus times minus is plus. So 3 times 3, 9. Over 4 times 4, 16. This will give us 16. Then minus 81 over 16 into brackets. Look at this here. I'm having minus 3. You know, minus become 1 over. So inverse in here. I'm adding 4 over minus 3 raised to power 3. Minus here equal to okay, this is okay. So here now, I'm having, you know, this means times. Bracket is the one mean. 27 year 1, 27 year 3. I mean 32 year 1, 32 year 2. So here I'm having minus times 1. Minus times 1, that's minus 1 over 3 times 2, 6. Minus what I have next? 16 year 1, 16 year 4. 9 year 1, 9 year 3. Minus 4 over 3. Then minus 81 over 16. Then everything raised to power 4 raised to power 3 is what? Additional 4 raised to power 3 is what? 64. Over minus 3 raised to power 3 is what? Minus 27. I mean, so minus 27 here 1 as well. 27 here, what do I have there? 27 here what? 3. I mean, then 16 year 1, 64 year 4. I mean, so I'm having minus 1 over 6, minus 4 over 3, minus, I'm having minus 1 here. I mean, you know, I'm having minus 27 here, right? So I'm left with minus 1. 3 times 4, you know, I'm left with 3 here, I'm left with 4 here. 16 here, 16 here, 4. 3 times 4 is 12, so I'm having minus 12 here. So here I'm having minus 1 over 6, minus 4 over 3, then plus, minus times minus, plus 12. I hope you guys are with me. So have you guys gotten the LCM here? Here should be, I'm having LCM here over 1. LCM here should be 6. 6, I think it is minus here. I should be having minus there, yeah. I'm having minus 6 and 6, 1. 1 times minus 1, minus 1. Minus 1. Minus 3 in 6, 2. 2 times 4, 8. Plus 1 in 6, 6 times 12 is what? And that's 72. So what do I have here? Minus 1 minus 8 is minus 9 plus 72 over 6. What was minus 9 plus 72? That's 72 minus 9 approximately. 72, 7. That's 63. 63 over 6. 63 divided by 6. In 60, that's 10 whole number. Oh, sorry. It is not 10 raised to power 3 over 6. That means it is 10 whole number 3 over 6. What's the option? You're raised to power 3. So it is 10 whole number 3 over 6. That means my answer here is. Till answer. 3 year 1, 3 year 2. This can be 10 whole number 1 over 2. 10 whole number 1 over 2. My answer there is A. My answer there is A. That's 21 over 2. Yeah, 3 can go here, 3 can go here. So it is correct, 21 over 2. 10 whole number 1 over 2. Now from here, I will give you guys assignments. I'll be dictating the assignment. So you guys should please listen and listen well. Listen attentively. Are you guys with me? Listen attentively. Listen attentively. So here, the first question here is 18 raised to power 2 over 3 times 12 raised to power 1 over 3 equals 2 raised to power m times 3 raised to power n. 18 raised to power 2 over 3 times 12 raised to power 1 over 3 equals 2 raised to power m times 3 raised to power n. One, find the value of m plus n. The answer you have to get there should be 3. The answer you have to get there should be 3. M raised to power. So if you have any question, probably I might be doing another video based on for the correction of all this. So I'll be doing another video for the correction. Number 2, 2 raised to power 1 over 2 times 3 raised to power 1 over 2 times 6 raised to power 1 over 2 times 8 raised to power 1 over 3 times 27 raised to power 1 over 3. That's number 2. Should I give you guys answer again? The answer there should be 36. 36. The next one is the cube root. Open bracket first. Open bracket. Then cube root. This cube root. When I say cube root, I have to root right. Open bracket first. Then 3 cube root. Then under the root. Under the root, you are going to write 64a raised to power 3. Then close the bracket. Then put minus 1 over 3. The answer there should be 1 over 4a. That should be your answer there. I can give you guys 1, 2, 3 questions. Let's make it 5, sure. Next one, 27 raised to power minus 2 over 3 times 25 raised to power 1 over 2 times 5 raised to power 0 times 5 raised to power 0. The answer you have to get here should be 5 over 9. Then the last but not the least, open bracket 0.8, close the bracket, raised to power 3, times open bracket 0.05, close the bracket, raised to power 2 over 0.3. You have to simplify it. The answer you have to get there is 0.004. So I'll be recording another video for the correction of all these assignments. So you guys should stay tuned. Thank you very much.